All right, so we are on journal 50. That is half of 100. Okay, maybe it's not that special, but to me, we've hit a big number, at least in my opinion. So, taking a look at this spell work here, all it's asking you to do is to rewrite the exponent so that you can solve for x. So we're solving for x here, so we have to get x by itself. So one way we can do this, we learned last unit, is we can change it to an exponent. And one method you could use to change it to the exponent is the Hart method, if that's what you're comfortable with. So make sure that the log is on the left-hand side, and it is, and so is this one. So it's ready to use for the Hart method. So I'm gonna go ahead, and if you remember, we always start with the base. So the base is the number that is the very small subscript here. So in this case, our base is 4, and we're going to the 3, and then we hit the x, and we make a heart when we do that. So this is really, looks like it's going from 4 to 3, so that's saying 4 to the third power equals, and where do we land? We land on x, so this equals x. Okay, notice that x is by itself, but we need to figure out what 4 to the third power is. So 4 to the third power is 4 times 4 gives me 16. 16 times 4 gives me 64. So x is equal to 64. And so I have found what x is. All right, let's try that with part B. So I'm going to start with my base, which is a 2. And I'm going to go to 5. So this is 2 to the 5th power. And then if I complete my heart, I land on this x minus 1. So this equals x minus 1. And so when I look at this here, maybe to get this x by itself, maybe perhaps simplify this part. So 2 to the 5th power, that's like multiplying 2 5 times. So I know 2 to the third power is 8. 8 times 2 gives me 16. 16 times 2 gives me 32. And feel free to do this part in the calculator. You can always go to the calculator and do powers. So this is 32 minus x, x minus 1. And so now I'm going to try to get this x by itself. So it looks like I just need to add 1 to both sides. That cancels. So x is equal to 32 plus 1, 33. So x is equal to 33. All right, so that's what we're going to be doing today is trying to solve for logs. And you can see that we always try to solve for logs by changing it into an exponent and then trying to get the x by itself. And you can use the Hart method to do this. But notice that these problems, a log was already by itself. There was nothing that was kind of to the side of the logs, right? There's nothing in front of the log or there's nothing to the side of it. So we're going to look at more log equations where it gets a more stuff on the equation. And so we're going to see that in the next slide here. Okay, so 2 things you need to know for solving logs. 1, you have to make sure that the log is by itself first, because you can't change it to an exponent until the log is by itself. So 1, you got to make sure the log is by itself, then you can rewrite it as an exponent form to solve for x. So let's take a look at the first one here. Notice that this log here, right, let me grab a highlighter, starts with a log. What's my base here? Notice that there's not a base written. So if there's not a base written, then by default, the base here is 10, right? Because that's what we learned last week. If you don't see a base, it's always 10. And then afterwards, it looks like the log includes 3x minus 5. So this is all included or all encapsulated inside the log. What's not included inside the log is this 3. That's an outside the log number. So in this case, I got to get rid of the 3. So I'm going to divide by 3 to get rid of it, because the 3 is sitting next to the log. So this is implying multiplication. So I have to divide it off. So I have to divide 3 to the other side. So the 3's cancel. So now I just have log base 10, 3x minus 5 equals 6 divided by 3 is 2. And so now notice the log is by itself. So I'm going to try to switch it to an exponent by using the Hart method. So I'm going from the base. So this is 10 to 2, then to 3x minus 5. So this is 10 squared, 3x minus 5. And now I'm going to try to clean this up by trying to get x by itself. So like on this side here, I can do my exponent first. So 10 squared is just 10 times 10, which is 100. Then I have 3x minus 5. So I'm going to try to get this x by itself by first adding the 5 over. You want to add first. And actually, let me show you why you want to add 5 first. If you didn't add 5 first, here's what would happen. You would have to divide this x by 3, and then you would have to also divide the 5 by 3, and that's kind of a mess. And you would still have to divide the 100 by 3. So to avoid all this madness, we just start by adding the 5 over first, because that's a lot easier. So the 5 cancels, and now I have 3x equals, well, 100 plus 5 is 105. Okay, now to get rid of this 3 on this x, I'm going to divide by 3. 3's cancel, so x is equal to 105 divided by 3. That is 35, if you plug that in a calculator. So x is equal to 35. All right, so we're going to use that same technique here on this side. So let's take a look at our logs here. So our log here has a base of 3, so that's included in the log. And then we have a minus x plus 7 that's also included in the log because it's using parentheses to encapsulate it. But what's not included in the log is this plus 1, so we have to remove it. So we remove it by subtracting, right? So we're going to subtract off 1 to both sides, so that cancels. And so now I have log 3 minus x plus 7 equals 5 minus 1 is 4. So now what I can do is I switch it to an exponent because my log is now by itself, right? There's nothing attached to it anymore on the outside. So I'm going to use the Hart method to switch it to an exponent. So this is 3 to the 4th power equals negative x plus 7. So, okay, maybe let's take care of the exponent here first. So 3 to the 4th power. I use that in my calculator here, or you could do this by hand. If you multiply 3 4 times together, if you multiply 3 4 times, it is 81. Then I have a minus x plus 7 on this side. So I need to remove this 7, so I'm going to subtract 7 from both sides. That cancels, and so I have negative x equals 81 minus 7 is 74. Okay, so now we have to get rid of this negative on the x. How do you get rid of a negative sign? Well, one way to do it is you can divide by a negative 1. So if you divide negative 1 on both sides, negative cancel on the right-hand side. And so now x is equal to, well, 74 divided by negative 1 is negative 74. And that's it. X is by itself. So we're done. Okay, let's try a few more log problems. All right, so here we have a few more log problems. So the same rules still apply. One, you got to make sure the log is by itself, and we're pretty lucky here. Notice that log here is by itself. It has a base and something included, but there's nothing attached on the outside, and so is this one. So the log is by itself, so the next step is to make it an exponent. So we can use the Hart method here. So we're going to go from 8 to the fraction. So this is 8 to the 4 over 3 as a power, so the fraction is a power, and then we would land on x, so this is equal to x. Well, what is 8 to the 4 over 3 power, right? So how do I do a power when it's a fraction? Well, you could do this part straight in the calculator, and I'll show you how here in a sec. But let me set up both of these problems before I show you the calculator. So this one here, I'm going to do the same thing. I'm going to start from my base to my fraction and then land on my x. So this is 243 to the 2 over 5 power equals x. So I'm going to actually plug this part in the calculator to get what that value is. So on here, I am going to grab my calculator, make sure the video is on, and I'm going to flip my camera. There we go. And I'm going to do it right here. Maybe we're going to do it this small. Let's see if this works out. Okay, so my camera is on, And hopefully you can see the screen here. So what you have to do is, maybe zoom out just a bit. There we go. And I'll get closer to the screen here. Or maybe if I move to the light, sorry, readjusting here. This might take a while for me to figure out the lighting issue. Maybe that's better. Yeah, that's a little better. Okay, so what we're gonna do is get that 8 to the 4/3 power. So I'm gonna make sure I have an 8 in here. As you can see, that is an 8. And now I have to press this caret button, what we call, and it gives you your power. So notice it just raised it to a power. Now I can put in the power, which is 4/3. Now if you wanna do fractions, you can actually use division to represent that fraction. So what I mean is, instead of 4/3, you can do 4 divided by 3. Notice it looks like a division sign, right? But that actually represents a fraction. And so if I hit enter, oh, I get 16. So on here, I can write x equals 16. So I'll do that here in a sec, but let me try to get the other value. So the other one is 243 raised to the, let's see, 2/5. So 2 divided by 5 as my fraction. And boom, I get my answer to be 9. And so I'm going to write these down now here on the side. So I'm going to pause this. There we go. So the first one for A, x was equal to 16. So I'm going to box that answer because now x is by itself. And this one here, x was equal to 9. And box that in. And there we have it. We can use the calculator to our advantage here to figure out fraction exponents. Now, here's how you would do it by hand. It's a bit tricky, and you're not expected to do it by hand. But for those of you who are curious, basically what you would do is the fraction, the denominator, tells you what root to take. So if you take the cube root of 8, well, if you do that, you get actually 2. So then you look in the numerator. The numerator tells you what exponent to take. So if you have a 2 to the 4th power, that actually gives you 16. So that's how you do it. Basically, fractions as a power, the denominator tells you what root to take, and then once you take the root, then you can use take the exponent of that number. It doesn't matter which order you do it. You could take the exponent of it first, so like 4 to the 8 to the 4th power, and then take the cube root of it, or take the cube root and then take the 4th power. So that's how you would do it by hand. But like I said, you can use the calculator for this part and just plug it in and get a number. All right, let's try something else here. There is a special type of log that we're going to talk about here in the next slide. Okay, so there's a special type of log where the base is e, okay? And we call this log the natural log, and we represent it as ln. And so on your calculator, and actually let me show you this on the calculator. Let me grab that video recording. Let's see, let's make a video. And so I'm gonna flip my camera, and then I'm gonna show you on the calculator because I think some of you have already started to see this. So let me see here. So on the calculator here, and don't worry about the screen so much, I want you to focus on the buttons here. You might have noticed when you look at a graphing calculator and you want to figure out where E is, it's right here, right? And it's in blue, if you notice. Let me try to do this with better lighting. There it is. There's E to the X. And anytime you want to grab this E, you have to hit second, this blue button, and then ln. So you've been actually pressing this button for a while, but what the heck is ln? Well, that's really representing log with a base of e. So ln is a special type of log that we use. And so notice that these two buttons, so ln and e, go kind of hand in hand because they're inverses of each other. So to undo e's, we use ln, and to undo ln's, we use e. And I'm going to show you that today and how we use it to undo each other. So let me just stop this recording and put this to the side here. Let's stick it right there. Yeah. Okay. So on here, To represent E, I don't actually write it this way, like it's printed as an L and an N. So I actually write it in cursive. Anyone want to guess why I write it in cursive? So I write it as ln in cursive, and then I write an X. Well, it's because when you write it as L and N like this, notice that that L really looks like a 1 next to the N, which can cause a lot of confusion. So a lot of times mathematicians and people who do a lot of math will write ln in cursive and then everything else normally, just to avoid that mix up. So I really encourage you to write it in cursive, but you don't have to, as long as you know that that is an L and not a 1. Okay. So what this is this ln represents this portion, the log base e. So instead of writing log base e a dozen times, you can just write it as ln. So what we're going to do here is solve a problem that uses ln. Okay. So I'm going to show you 2 ways you can solve this problem, and you choose which way you prefer. So I'm going to drag this this up a bit. Let's see here. Yeah, there we go. So let's make maybe 2 columns. Let's say that this is our first method, and this is our second method. So the first method I'm going to do is something that you guys are familiar with, is with logs, okay? So what I'm going to do is change, let me actually rewrite the problem. So this is ln of x equals 25 is what I'm trying to solve. And so instead of writing ln of x in this equation, I'm going to replace it with what it represents as a log. So I'm going to replace this as log ex equals 25. So all I did was replace the ln with what it represents as a log. Because when you see a problem like this, then this goes back to what we were doing a moment ago. We want to try to get the log in exponential form so we can solve for that x, right? So this is like, oh, I got to do the Hart method to change to exponent. So I'm going from e to 25 to x. So this is going to be e to the 25 power equals x. And remember, e is just a constant, so it's not a variable. So in this case, I have e to the 25th power, and I can put that in my calculator and get a number. Now, I'm not going to expect you to do that here, but it looks like x is by itself, so looks like we're done. So once you get x by itself, you can keep it that way. Okay, on this side here, I'm going to do the exact same problem, ln of x equals 25, but this time around, I'm going to solve it just a little bit different. So another way you can solve it, and this is a way that a lot of college kids solve this problem, and a lot of college professors teach it this way too. So that's why I want to show it to you, because you might prefer this way over this first method. Okay, it's a little bit faster, and also in college, you're not going to be shown that way. The rewrite way, okay? So I want to let you know you can also do the problem this way just in case you see it in college and you're like, what the heck just happened? So what you do for type 2 is you can try to cancel out the ln, and in order to cancel out ln, well, the inverse of ln is e, so we use e's. And so we're going to e it, is what we say. When we e it, what happens is the e and the ln cancel, and so now the x drops down. But anything you do to one side, so if you e this side, you gotta e this side. So now I have to e the 25. And notice that I placed the e on this side in front of the ln to cancel that one out. Well, that means I need to place that e on the front of the 25. So on this side here, on the left-hand side, I just have x left. The e only cancel out the ln, so x drops down. And then I have an equal sign. And then on this side, I have e to the power of 25. The 25 ends up being a power. So this is e to the 25th power. That's the same answer we got last time, but I just did it in one step. I didn't have to rewrite the function and then do the Hart method. What I did was I tried to cancel out that ln by using e on both sides to cancel out that ln, and then this side here I just had an e, right? So looks like this is my answer because x is by itself. So you choose which method you prefer, but from now on, I'm actually going to use the second method more often to solve these natural log problems, okay? So just as a fair warning, I'm going to use this method just because it's a lot less writing. All right, so let's solve a couple more of these natural log problems just to give you some more variety. So just like the logs, natural logs, you want to make sure the natural log is by itself before you try to cancel out that natural log. So natural logs, the way that it's written, it has an ln and then there's something inside the parentheses or something next to it, okay? It doesn't have to have a base written in between the parentheses and the ln, because the base here is implied. When you see the ln, it's implied that it's e. So like this one here, let's make sure that this ln is by itself. So this ln has an ln and then there's stuff inside the parentheses. So yeah, this ln's by itself because there's nothing outside of it to the left or like to the right here. So to get rid of ln, I'm going to, let's see, to get rid of ln, we learned a moment ago, is that we can e it, or we can put an e next to it. And that means we have to e the other side. So the e and the ln cancel out. So now I just have x minus 3 that comes out, or comes down. And then the other side is e to the 7th power. Remember that 7 becomes an exponent for the e. The e acts as a base. And so now, this side here, I'm just going to keep it as e to the 7. I'm not going to try to calculate that or put that in my calculator yet. But I do need to try to get this x by itself. So it looks like I need to add 3 to both sides. So I'm going to do that here. If I add 3 to both sides, this 3 cancels. So now I have x equals e to the 7 plus 3. And I can leave my answer just like this. This is totally fine to leave. Or if you want to know what that value is, you can put this in your calculator. So just when you're doing that, you're going to hit second e to the 7th power and then add 3 to it. And so that gives you about x equals 1099. I'm going to just round to 3 decimal places, so 633. So I use the calculator to get this answer. But know that you can leave your answer right here. You don't have to get the decimal form. It's just for those of you who want to see what the actual number is. Okay, so for part B, let's take a look. So this one here, I want to make sure that the natural log is by itself. So this natural log has a ln of x, but the question is this -6 attached to it? And the answer is no. Because if it was attached, it would have had parentheses wrapped around it, right? To say that this -6 was encapsulated in the ln, but there's no parentheses here. So in this case, I can only assume that ln of x is the only thing that is encapsulated. In other words, the x is the only thing encapsulated inside this ln. So I have to remove this 6 and this 3. So remember, we have to add the 6 over first. You don't want to divide first. And then we have 3 ln of x equals 9 plus 6 gives me 15. Then I have to divide by 3. And so that cancels. And then I have ln of x equals 15 divided by 3 gives me 5. And then I have to get rid of this ln next to x. And how do we do it? Well, in order to do it, we have to e it, right? So I have to e this side. So I'm going to e this side and then e the other side, and that cancels. And so x drops down, and I have e to the 5th power, and I have arrived at my answer. Now, if you want to know what it is in decimal form, or the actual value, well, let's see. If I hit second ln in the calculator and raise it to the 5th power, I get about 148,413 in decimals. And so that's it, guys. So that's journal 50 there. I hope this is going to be helpful for you guys. So these problems are going to be very similar to page 2 of packet 11. So take a look at page 2 if you haven't yet and try out some of these problems.